there! Did you know that metadata is like the superhero sidekick of computer files? It's a special type of data that tells us important things about other data, like files. Imagine you have a treasure chest full of toys, and each toy has a little tag that tells you what it is, who owns it, and when it was last played with. That's metadata. Now, why should you be interested in metadata? Well, think about when you want to find a specific toy in your messy room. If you know its name, owner, or when it was last used, it becomes much easier to find, right? Metadata helps you manage your files just like that. It tells you what type of file it is, who can access it, and when it was created or changed. But wait, there's more. Understanding metadata can also help you keep your files safe. You see, metadata helps us check if a file has been changed or if it's the same as before. It's like having a special seal that shows if someone tried to sneak into your toy chest without your permission. Oh, and here's something cool. If you're into solving mysteries, metadata can help you investigate digital clues. It can tell you when someone last opened a file, who did it, and even help you figure out the order of events. It's like being a detective, but in the digital world. Metadata is also useful for making things faster and better. It helps computers organize and find files quickly, so you don't have to wait for ages when searching for something important. It's like having a magical power that helps your computer run smoother. So, my young friend, by understanding metadata, you can become a master of file organization, keep your files safe and secure, solve digital mysteries, and even make computers faster. It's a superpower that will make you a tech-savvy hero. Isn't that exciting? Metadata refers to data that provides information about other data. In the context of files, metadata is associated with a specific file and helps describe its attributes. For example, when dealing with a photo file, the metadata may include details about the photo itself, such as the date taken, camera model, and resolution. Additionally, the operating system adds its own metadata to the file, which aids in managing and organizing files effectively. Understanding the attributes of files is important. Let's go through each metadata item in Linux. File type. The file type metadata represents the type of file it is, such as text, image, or executable. It helps determine how the file should be handled and interpreted. File extension. The file extension metadata represents the extension of the file, such as txt, jpg, or exe. It is usually appended to the file name and provides additional information about the file type. Permissions. Permissions indicate the access permissions for the file. They determine who can read, write, or execute the file. The permissions are set for the owner, group, and others. Owner. The owner metadata specifies the user who owns the file. The owner has certain privileges and control over the file, such as changing permissions or deleting the file. Group. The group metadata denotes the group associated with the file. Users who belong to the same group may have certain shared access rights to the file. Size. The size metadata indicates the size of the file in bytes. It represents the amount of storage space the file occupies on the disk. File location. The file location metadata specifies the directory path where the file is located. It provides the file's location within the file system hierarchy. Number of links. The number of links metadata denotes the number of hard links pointing to the file. A hard link is another name for the same file, and multiple hard links can exist for a single file. Inode number. The inode number metadata is a unique identifier for the file in the file system. It serves as a reference to the file's metadata and helps track and manage the file within the file system. Number of blocks. The number of blocks metadata represents the number of disk blocks allocated to the file. File data is stored in these blocks on the storage device. I/O block size. The I/O block size metadata specifies the size of the input-output block for the file. It represents the minimum unit of data that can be read from or written to the file. Device number. The device number metadata indicates the device identifier associated with the file. It identifies the storage device where the file resides. User ID. The user ID metadata represents the user identifier of the file owner. It uniquely identifies the user within the system. Group ID. The group ID metadata denotes the group identifier of the file owner's group. It uniquely identifies the group within the system. Last access time. The last access time metadata denotes the timestamp when the file was last accessed. It records the last time the file's content was read or its metadata was retrieved. Last modification time. The last modification time metadata represents the timestamp when the file was last modified. It records the most recent time the file's content was changed. Last metadata change time. The last metadata change time metadata indicates the timestamp when the file's metadata was last modified. It records the most recent time any of the file's metadata, excluding content, was modified. File birth created time. The file birth created time metadata represents the timestamp when the file was created or born. It indicates the initial creation time of the file. These metadata items provide valuable information about files in a Linux system, enabling users to understand and manage their files effectively. Now, let's talk about the commands. File. This command is used to determine the file type based on its content. It provides information about the file type, such as whether it's a text file, image, or executable. LSL. This command is used to list detailed information about files and directories in the current directory. It shows the permissions, owner, group, size, and timestamps of the files. Stat. This command is used to display detailed information about a file, including file size, number of blocks, I/O block size, device number, user ID, group ID, and various timestamps related to file access, modification, metadata changes, and file birth creation time. Let's run each of the commands and have a look at them in detail. Let us execute the file command. Let's break down the output. The command file sample.txt is executed, where file is a command used to determine the type of a file. In this case, it is used to examine the file named sample.txt. This line indicates that the file sample.txt is being analyzed. The word empty suggests that the file is indeed empty, meaning it does not contain any data or content. In summary, the command file sample.txt was used to determine the type of the file named sample.txt, and the output indicated that the file is empty. Let's now take a look at the ls command. The output provided is the result of the ls command executed on the user's home directory. Let's break down each line and explain the information it contains. The first line, total 60, indicates the total number of blocks used by the listed files and directories. This line starting with drwxrxrx represents a directory. Here's a breakdown of the information. drwxrxrx, the permissions for the file or directory. In this case, the directory has read, write, and execute permissions for the owner, and read and execute permissions for the group and others. 2. The number of links pointing to the directory. Doros, the owner of the file or directory. Doros, the group associated with the file or directory. 4096, the size of the directory in bytes. June 12, 1059, the timestamp indicating when the directory was last modified. Desktop, the name of the directory. Similarly, the subsequent lines represent different files and directories in the user's home directory, providing information such as permissions, number of links, owner, group, size, timestamp, and name. It's worth noting that the format of the ls output is structured as follows: permissions, links, owner, group, size, modified date and time, name. Here's a breakdown of the different components. Permissions represents the permissions for the file or directory, indicating read, write, and execute permissions for the owner, group, and others. Links denotes the number of links pointing to the file or directory. Owner represents the user who owns the file or directory. Group denotes the group associated with the file or directory. Size indicates the size of the file or directory in bytes. Modified date and time, the timestamp indicating the last modification date and time. Name, the name of the file or directory. By analyzing the ls output, you can gather information about the permissions, ownership, sizes, and timestamps of the listed files and directories in the user's home directory. Let us move on to the last but not the least command, stat command. In the output, the stat command is used to display detailed information about a file. Let's go through each line of the output and explain its meaning. The command stat_sample.txt is executed, where stat is a command used to retrieve file or file system status. In this case, it is used to retrieve the status of the file named sample.txt. This line indicates the name of the file being examined, which is sample.txt. This line provides information about the file size. In this case, the file size is 0, indicating that the file is empty and contains no data. The blocks field also shows 0, indicating that no disk blocks are allocated for this file. The I/O block field specifies the input-output block size for the file, which is 4096 bytes in this case. The term regular empty file describes the file type. This line displays information about the device and the file's inode. The device field shows the device number, which is represented in hexadecimal and decimal formats. The inode field indicates the inode number assigned to the file, which is 394,097. The links field specifies the number of hard links to the file, which is 1 in this case. This line provides information about file access permissions, user ID, and group ID. The access field shows the file's permission mode represented in octal format. The permission indicates that the owner and group have read and write permissions, while others have only read permission. The UID field displays the user ID of the file owner, and the GIT field shows the group ID of the file owner's group. This line represents the last access time of the file. The timestamp indicates that the file was last accessed on June 20, 2023, at 18 hours 36 minutes and 38 seconds local time with an offset of 5 hours and 30 minutes indicating the time zone. This line represents the last modification time of the file. The timestamp indicates that the file was last modified on June 20, 2023, at 18 hours 36 minutes and 38 seconds local time with an offset of 5 hours and 30 minutes. This line represents the last change time of the file. The timestamp indicates that the file underwent a change on June 20, 2023, at 18 hours 36 minutes and 38 seconds local time with an offset of 5 hours and 30 minutes. The change time refers to modifications in the file's metadata. This line represents the birth or creation time of the file. The timestamp indicates that the file was created on June 20, 2023, at 1836. The stat_sample.txt command provides detailed information about the file sample.txt, including its size, device, inode, access permissions, timestamps for access, modification, change, and birth creation, as well as the user and group ownership. It also confirms that the file is empty.